sine function is the opposite over the hypotenuse. And in the coordinate system, that is going to be the y-coordinate over the radius of the circle if I think of it in terms of the unit circle. However, I can graph the sine function, if I choose to, in a more conventional manner, which is this represented right here, where this is the t-axis from the unit circle, the distance along the unit circle. And the range is still the same. The range of values goes from, on the unit circle at least, from 1 to -1. And the range here is 1 and -1. So I'm graphing this out instead of it in a circle as two lines like the regular coordinate system. But it's the same thing. If I start at 0, opposite over hypotenuse, it starts at 0, it starts at 0. As my t values begin increasing, as the angle begins increasing, the y values are going to increase. And I can see that increase on this graph from 0 all the way up to 1. And at that point, this is 0, 1, which means that the radius, which is 1 on the unit circle, will be equal to the opposite side. 1 divided by 1 is 1. And that is what I have here. At 90 degrees, pi over 2, I have 1. And then as I begin coming down the other side of the circle, sine is still positive because the y values are still positive. But the y value will begin decreasing. The radius remains constant throughout this entire circle. Y begins decreasing all the way until it reaches 0. So it starts at 1 again, 0 at 180 degrees. 0 drops down to pi, which is 180 degrees. Then the y values begin increasing in the negative direction, I can see that, and then I get to a point where I have -1 instead of 1. -1 divided by 1 is -1. And then it'll begin coming back down again, and the process will continue repeating itself in both directions. If I had started and gone down in the negative t direction, then I would have started approaching -1 first. So that is the more conventional graph of sine. As I can see, they are exactly the same. Now all I really want to do is talk about the possible transformations of sine function. And it's exactly the same as I learned in polynomials. If I add to the y value, I could think of sine x as x. That's why I wrote it in as x instead of theta. I want to think of this as I would a typical polynomial. If I had just sine theta of this regular unit circle, and then on top of that I added some integer value, 1, 2, 3, -1, -2, it would shift this. This is a vertical shift. And it's like the polynomials where if it's a plus, it's going to shift it up, and if it's a minus, it's going to shift it down. So this is what a vertical shift of a sine function would look like. I have the sine of some function x or theta or whatever it is, and then if I take the sine of that function and then add some integer value, that will shift it up or down. And likewise with horizontal shifts. In polynomials, if I had something directly subtracting or adding to the x value, this would be a horizontal shift. And if it was a minus, then that means it shifted it to the right. And if it was a positive, that means it shifted to the left. Because I can think of it as before as the same function but either happening sooner. If I added to it, that means that the values would occur sooner, or they would happen later, which would mean I would shift it to the right. if I subtracted them, because it would not happen as quickly. That's just the easiest way I've come to think of the shifts. And here, this is a horizontal, this is a stretching of the graph. And this is going to stretch and compress it horizontally. And again, it's exactly the same as polynomials. If I multiply the angle x by 2, say, that means that it will only take 180 degrees for me to go around the entire unit circle. So what will happen is it will compress the sine function. So it would look something like, oops, it would look something like this. Where I have, if I were to go 2 pi, then normally I would have only gone around one time. But if I had sine of 2 theta, then that means I would have gone around it twice. So this graph should make sense. So I've gone around it, this is what I would have gone around it once, but I've gone around it twice. And similarly, if I had done it something like this, then it would have taken me longer to go around the circle. It would take me 4 pi instead of 2 pi to go around the circle once. So if I were to do that in the negative direction, it would look like this. It would stretch the graph, because it would take more degrees in order for me to achieve the same thing. And then this would go all the way down at 4 pi. And then lastly, when I have some constant multiplied by the sine function, then this is going to affect the amplitude. If I multiply 2 sine theta, then this is just going to be twice as high instead. And that's all of the transformations that I really need to be worried about right now. It's exactly the same as polynomials, no different. It's just a sine function instead.